Hey everyone, we're going to get started today on our FRQ trainers. And what we've done basically is try to figure out the most common problem types on the AP Calculus test and really trying to hit those hard on exactly what kind of problems you're going to be expecting. So let's get started now, taking a look at the first FRQ trainer. So I don't know how many of you read any science fiction at all, but this is Dr. Susan Calvin is a fictional character appearing in Isaac Asimov's Robot series of science fiction short stories. According to iRobot, Dr. Susan Calvin was born in the year 1982 and died at the age of 82, either in 2064 or 2065. That's like a little ways off now, isn't it? In January 2025, Dr. Calvin bears witness to robots with their positronic brains. That's like a really big deal in those books. Being built at a rate modeled by RT equals 10 plus 6 sine pi t over 6 robots per day, where t is a number of days since New Year's Day 2025. Okay, so this sounds like a really esoteric setting, but it's really not that bad. You've got that one equation that you need to put into your calculator. So why don't you put that in your calculator right now? I'll do the same. Okay, things look pretty nice. So coming back to our problem, we're going to read through what we have here. Also, before I read this out to you, I'd like you to be aware that usually when you see these problems involving rate on the AP test, you're really looking at something that's going to be on the calculator portion of the test. So remember what that means. No solving on pen and paper, no derivatives on pen and paper, no integrals on pen and paper. So you're expected to do everything on your calculator. So at what rate are robots produced on January 5, t equals 5? Indicate units of measure. Is this rate that robots are being built increasing or decreasing? So is the rate going up or is the rate going down? Give a reason for your answer. How many robots are built in the first week of January 2025? T equals 0 to t equals 7. Round your answer to the nearest robot. Find the average rate that robots are being built for the first week of January. So that's a lot on our plate. 4 questions. Remember that if this was actually an AP test, this one question would be worth about 1/6 of your entire free response portion. So pretty weighty. Let's take a look at number 1. At what rate are robots produced on January 25? T equals 5. So, you're going to read through this. Notice that RT gives the rate that robots are being built. So you're just going to use your calculator to evaluate R5. And then you're going to write your answer, R5 equals something. Since the equation of R5 is given, you don't need to actually write anything. You just need to substitute and show your work. Okay. I would also like to add that it's probably a good idea for you to write a summarizing sentence at the end of this. So I'm going to model that for you as well. Let's see. What is R5? Well, I've got it in my calculator at Y1. So I'm just going to figure out what is Y1 when t equals 5. 13. Okay. So R5 equals 13. So that means that robots are being built at a rate of 13 robots per day. No work to show, no nothing. All you got to do is evaluate that function because that's all they're asking for. Okay, moving on to letter B. Is the rate that robots being built increasing or decreasing? So the question is, how can I tell if a function is increasing or decreasing? And the answer is you look at the function's derivative and see if the function's derivative is positive or negative. Positive derivative, of course, means that you have some growth. So we just need to evaluate r prime of 5. So we're just going to do that on our calculator. Let's write it here, start setting it up. R prime of 5 equals, here we have the derivative of y1, evaluate that when x equals 5, and we get a number negative 2.72. Okay, so r prime of 5 is negative 2.72, and what does that say? Well, that's a number that's less than 0. And I would put that less than 0 sign there. It is important in your analysis. So what does that mean? That means that our function r is decreasing. And what was r? R is the rate that robots are being produced. Therefore, the rate that robots are being produced is decreasing. Okay, so there we go with question B. Again, not too difficult. This first one contains problems that aren't necessarily the most difficult. You could also imagine that with these problems, if not a whole lot is required of you, then the point value of these are not going to be very much. So we're taking a look at problems that are 1 or 2 points out of 9 on the AP rubric. Let's take a look at the next one. How many robots are built in the first week of January 2025? So I always like to take a look at the units on this. You'll notice that the units are robots per day. So if you integrate robots per day, you're going to get an answer that is robots. Basically, it's going to tell you how many robots in the time period that you integrated. I have written here that the answer will give how many robots will have accumulated during that time period t equals a to t equals b. So how do you write this? Well, you write the integral. You put in RT inside the integral. You put in appropriate upper and lower limits. And then you write the answer. And then, of course, write a nice summary. So let's get our calculator out. And let's integrate. So here's our calculator, and we're integrating y1 from t equals 0 to t equals 7. That will be the first week. And what number do we get? 91.38307. Let's write that down on the paper now. And I know what you're saying. You're saying, well, aren't I supposed to round to the nearest robot? And yeah, you are going to round to the nearest robot, but you're going to round to the nearest robot when you write your summary statement. This is all the math you need to show. Now you just have to interpret your results in a sentence. So what is the interpretation then? In that first week of January, 91 robots are produced. This is where you are doing your rounding when you're presenting answers. So remember, this is an English class. You don't have to write it so that it's the most elegant thing on the planet, but you do have to write something that makes sense. I can think of a couple of different ways that this sentence would be structured. Don't worry about it too much as long as you get something on paper. As long as you rounded that to 91, you're going to be good. Let's take a look at the last one, letter D. Find the average rate that robots are being built on the first week of January. So the average of anything in calculus, I don't care what it is, I don't care what you're averaging, I don't care what they taught you in middle school, I don't care what they taught you in physics. If you are averaging something in calculus, it is an integral expression. Bank on it every time. So we need to figure out the integral expression for average. I see it written on the paper over there, so we're just going to write it down. What function are we averaging? We're averaging the rate. So dissect that again. On the physics side of things, you're used to reading this as average rate, right, as one thing. But that's not the way we're looking at it, or we should be looking at it. We should be looking at it as the average of the rate. So we're averaging the rate. Okay? That's the key. We're averaging the rate. So when I write my equation, I'm averaging the rate. Not finding the average rate. I'm averaging the rate. Semantics, right? Okay, we have an expression here, and it's already on our calculator. So let's pull that up, and let's just divide that answer. Actually, let's take that entire integral, and let's just divide that by 7, and that should give us results. 13.054. So there is the brute mathematics of the entire thing. The next thing here is to write down a summary sentence, which I'm always in favor of. So let's get that down here. There we have it. In the first week of January, robots are produced at an average rate of 13.05472 robots per day. Remember that this is an average, and for averages, you do not need to round anything. You don't need to truncate. I know we're talking about robots, and those are discrete objects, but it is not appropriate for you to just say 13 robots per day. 13.05472. Anytime you have an average, you don't have to turn that into discrete objects, especially on the AP test. If they don't say to round, you don't round. Let's take a look at the very end, the important ideas. Here we go. So first off, R in these problems is always a rate, and that would mean something per unit of time. How many things are being produced? How many, I don't know, however, whatever it is. R prime, however, is the rate that the rate changes. So if R prime is greater than 0, the rate is increasing. If R prime is less than 0, the rate is decreasing. The integral of RT tells you exactly how many objects are being produced in that time interval, A to B. And of course, the 1 over b minus a multiplied by the integral is going to give you the average rate of R on that same time interval. And as an extra note here, we have, if this is the calculator section, don't do it. Don't integrate or differentiate on paper. Do it on your calculator. They assume you have a calculator. They know that you're going to do it on the calculator. And even better, they want you to do it on your calculator. So don't try doing it by hand. You're going to lose points. Trust me. Let's look at this check your understanding. And this check your understanding is actually an AP problem. I don't remember what year this is, maybe 2004. Traffic flow is defined as a rate at which cars pass through an intersection measured in cars per minute. The traffic flow at a particular intersection is modeled by this function. They give you a nice domain for t from 0 to 30. So to the nearest whole number, how many cars pass through the intersection in a 30-minute period? So if F is measured in cars per minute, and I want to know how many cars, I just integrate from 0 to 30. Let's do that real quick. Throw that in your calculator. There we go. Functions in the calculator. Get to the home screen next and evaluate the integral. Integral in the calculator. 2,474 cars. 0.07750 cars in that first half hour. Let's go write that down on our paper. There we go. Integral, unrounded number, sentence to explain the work. 2,474 cars passed through the intersection in the first half hour. Is traffic flow increasing or decreasing? Traffic flow is that function f, so this is saying f prime. Is that positive or negative at 7? Let's calculate that real quick. Grab your calculator. Okay, got the derivative inside the calculator. Pushing enter, we get negative 1.87291. So that derivative is less than 0, so that says to me that traffic flow is decreasing. All right, so again, write down the equation and then write down a sentence. Derivative equals negative 1.87291. Show that it's less than 0 explicitly, and then say since f prime of 7 is less than 0, the traffic flow is decreasing at t equals 7. What about letter C? Is the average value, or what is the average value of the traffic flow from 10 to 15 indicate units of measure? Okay, we trained for this. Average of anything is the integral expression. So what is the average of the traffic flow? That's the integral expression involving the traffic flow formula. So let's write that down first of all. Wait, what am I saying? Let's do this on the calculator first of all. So look, no one's going to judge you if you put 1 over 15 minus 10 on your calculator. And, don't stress about it. Just put 15 minus 10 or put 5. Doesn't matter. Just push enter here. We'll get a number of 81, about 81. And we're going to do the exact same thing. We'll write the formula, write down the number, and then we'll write down a summary. Equation equal to 81.89924, and then summary statement on 10 less than equal to 50, less than equal to 15, average traffic flow is 81.899 cars per minute. Okay, remember also when you're writing that your answer, even in your summary, you really need to go to 3 decimal places. No one's going to be mad if I put a 2-4 there, and I often tell people just to put the 2-4 there, even if they are, if they're confused or they don't know what to do, just write everything to 5 decimal places. But you do need at least 3, and all 3 of them need to be correct for this to be considered a correct answer. Lastly, what is the average rate of change of traffic flow over the interval from 10 to 15? Indicate units of measure. Whoa! Average rate of change of traffic flow? What are they even talking about? Okay, I know that the average of anything is that integral expression. So whatever I'm putting in there needs to be next in the sentence. So the average rate of change of traffic flow. So now you've got to think, what is the rate of change of traffic flow? Well, what is the rate of change of anything? It's the derivative. So if you want to find the average rate of change of traffic flow, well, that's the average of the derivative of traffic flow. Oh, now it's making sense. So this says I need to take the average formula that I use for everything in calculus, which is 1 over 10 to 15, and in there, I need to put the derivative of traffic flow. Remember, the derivative of traffic flow is the rate of change of traffic flow. So f prime of t dt. How am I supposed to do that? Ferreira, you just told me not to take the derivative of anything on the calculator if you don't have to, or on the calculator section. And I'm still holding to that. There's a trick here. And the trick is you are looking at the fundamental theorem of calculus. the integral of the derivative of f is f. This is just f15 minus f0. Again, they're hoping that by putting all of that verbiage in letter D, they've pulled your mind away from what you're actually looking at. You're looking at the integral of a derivative, which on any other day, on every day, the integral of a derivative of a function is the function. So all we need to do is 1/5 of f15 minus f0. Grab your calculator and let's do that. Here we go. I just went 1/15 minus 10, and then I have y15 minus y10, and I'm looking at the work over here, and it looks like I forgot to make this a 10. Well, we'll fix that later. Okay, so that is 1.517. Okay, so what does this mean? This means that on the interval from 10 to 15, the traffic flow is increasing because the derivative is positive at a rate of 1.517 cars per minute per minute. I know those of you out there are going to be tempted to write cars per minute squared. No, it's increasing at cars per minute, not minute per minute, but cars per minute. Okay, so that is what we're looking at here for this free response question. So that takes care of it. This is your first day worth of calculus FRQ training. Hopefully you can take these concepts and then use them for the to good use anytime you need to do an AP calculus test. This question type appears on both the AB and the BC exams. So if you have your friends in AB, you might want to point them over here in this direction. I'll see you guys next time with more Calculus Trainer.